Okay, here we go with our first lesson, Chapter 1, Lesson 1, about variables and expressions. Variables and expressions. Let's take a look. We'll see what we've got. In the past, you performed operations on integers. Integers were positive and negative numbers, just numbers. Now we are going to add in some algebraic expressions, which means if you have an algebraic expression, you're going to include some variables along with those numbers. And we are going to write algebraic expressions for verbal expressions. We're going to take words and create algebraic expressions from them, or vice versa. So here's a list of vocabulary. A lot of these words, if not all these words, should have been things you learned last year. All these words should be familiar to you. If there's any words there that you don't recognize and you don't know what they mean, pause the video now. Take a look in the glossary or Google them, see what you think, and see if you can figure out what they mean. So we're going to write some verbal expressions first. We're going to take an algebraic expression like this, and we're going to make a verbal expression out of it. You're going to create words. Well, you know that this 2 up here is a power to the x, and you know the 8 in front of the x is a multiplication. So in this case, it's 8 times x to the second power, or 8 times x squared. Remember, second power is called squared. So you could write 8 times x squared, or you could have written 8 times x to the second power to be a verbal expression for this algebraic expression. This one, I have a power of this variable, and I have a subtraction, and I have a number multiplying a variable after that. So one of the possible ways, and there's not just one way to write this, there are multiple ways to write this, would be y to the 5th power minus 16 times y. Notice I said 16 times y. I didn't just say 16y. I'm not just reading it. I'm writing an expression, a verbal expression to represent it. So the 16 is multiplying the y. You have to identify the fact that it's multiplication by saying times. If you just say 16y, you're not identifying the operation that's in that problem. So for this one, I have a 7 multiplying an a who has a 4th power. So 7 times a, that's not good enough. 7 times the product of 4 and a. Well, a and 4 aren't multiplying each other. That's not good enough. 7 times a to the 4th power. Sounds pretty good. 4 times a to the 7th power? No way. Those numbers are backwards. C is my answer. I have a power of x, second power, or a square, and I'm adding 3. The sum, remember sum means addition, we'll talk about that in a second, of 3 and x, no, it's not just x, it's x to the second power, or x squared. The product of x squared and 3, no, because product, remember, means multiplication. The sum of x and 3 squared, almost, but 3 is not squared, x is squared. So it's got to be D, right? The sum of x squared and 3. So again, you may want to pause the video in a second. This is just a little chart showing you different words that mean different operations. There's a list of words for addition. This is by no means the only things you could use to add, but it's a short list of words that mean addition. A list of words or phrases that mean subtraction. A list of words that mean multiplication. And a list of words that mean division. One of the things I would add to division is split evenly. If you're splitting something evenly, you're dividing. The other thing about this multiplication list, the word of. Of means multiplication, but usually it means multiplication with a fraction or a percent, like half of something, or a third of something, or percents, like 35% of something. So of means multiplication, but usually associated with fractions or percents, which I know you love both of those. So now we're going to take words, we're going to make an algebraic expression from them instead. It's 9 plus the product of 2 and d. So 2 and d are a product, that means they're multiplying, and 9 plus means addition. So plus indicates add, product indicates multiply. So here we go, 9 plus 2d. You also could have written 2d plus 9 because addition is reversible. That's the commutative property. We'll talk about the properties in a future lesson. But you should know the commutative property, and you should know that the addition can be written either way. 5 less than the number c. This is a problem. 5 less than something means you have to take 5 away from something. So a common mistake, well, first of all, less than indicates subtraction. Let's get that out of the way. So less than indicates subtraction, and subtraction cannot be reversed. Subtraction is not commutative. So if you have to do 5 less than something, 5 has to be taken away from something. In this case, 5 is being taken away from c. So the only way to write this properly is c minus 5, not 5 minus c, because if you do 5 minus c, now you're doing c less than 5. But it's 5 less than c. 5 is the thing that's being taken away. So with subtraction, be careful, because with the phrase less than, sometimes the order is going to be really tricky, confusing a little bit. 2/5 of the area A. A is the variable they tell me to use. 2/5, there's my fraction, and there's that of to multiply. Of indicates multiply, so it's 2/5 times A. They wrote it a different way too, this 2A over 5, because really this A is A over 1, because any whole number or variable can be put over 1. So if you were to take this A and put it over 1, and then combine the fractions by multiplying, the 2 would multiply the A and be together in the numerator, and the 5 would multiply the 1 and be in the denominator. We'll talk more about that as we go on too, about how a fraction can be written with a variable in multiple ways. So how about this? 9 more than the number h. You should know that more than indicates an addition operation. So it should be 9 and h being added together. They give us 9 plus h. You could have also done h plus 9 because addition is commutative. The difference of 6 and 4 times the number x. So difference indicates subtraction. And what are we subtracting? We're subtracting 6 and 4 times x. This one is 6 times x. That's no good. This one is 4 times x, but that's an addition. This is not 4 times x. This is subtracted and then add x. So A is my only answer. Difference of 6 minus 4x. This doesn't say 6 less than. It says 6. It says the difference. So the difference, when the difference is given in the words, in the verbal expression, you follow the order that the terms are given then. 6 comes first, 4 times x comes second. And the last one of these, 1/2 the size of the original perimeter P. Half of P, well, it's half times P. Another way you could have written this is, you could have taken this P and moved it to the numerator, because this is really P over 1. So it would be P over 2 when you combine the half and the P over 1. Different ways to write that. Understand that 1/2 of P is the same as P over 2. Because remember, taking half of something means dividing it by 2, and putting P over 2 would be dividing it by 2. They mean the same thing. Let's take a look at a word problem. Mr. Nehru bought 2 adult tickets and 3 student tickets for the planetarium show. An algebraic expression that represents the cost of the tickets. So we don't know how much an adult ticket costs. We don't know how much a student ticket costs. Those are 2 unknowns, and unknowns in an algebraic expression become variables. So I'm going to say to let A be the cost of an adult ticket and S be the cost of a student ticket. I really like to make the variables match the story of the problem, the words in the problem, so that I know exactly which variable means what part of the problem. You could use A and B, or the traditional X and Y, but if you use X and Y, well, does X mean adult or does X mean student? We don't necessarily know. If you use A for adult and S for student, there's no question. So 2 adult tickets would be 2A, and 3 student tickets is 3S, and his total cost is going to be those two prices added together, 2A plus 3S. And our last problem. Lorenzo bought a bag of peanuts. It cost P dollars. We don't know how much it was, but we know he gave the cashier a $20 bill. Write an expression for the amount of change he will receive. How much does he have to get back? Well, you know he's going to get less than his $20 back, obviously. The peanuts weren't free. But we don't know how much the peanuts were. So the peanuts are our variable. And we have to take the cost of the peanuts away from the $20 that he gave the cashier to get change. So we take the $20 that he gave the cashier, we subtract away how much the peanuts are, and A gives us our answer. Notice that B is the reverse of that, and with subtraction, you can't reverse the order. You're not taking $20 away from the price of the peanuts. You're taking the price of peanuts away from the 20 that he paid with to get his change. That's our final problem. It's time for you to do some practice. Have fun.